So let's do this problem where you're having four different sources: P1, P2, P3, P4. The coordinates are given 1, 1, 0, -1, 0, -1, -1, 0, 1, 1, 0, and four identical charges. And each of the charge is plus 3 nanocoulomb. So 3 into 10 to the power minus 9 coulomb. That's the each of those charges. Now you need to find what is the electric field at this location. Yeah, at this location of x is 1, y is 1, and z is 1. So at that location, what is the electric field? So the first thing you want to do is the destination r, the position vector at the destination r. So this being the destination, the position vector is x hat, y hat, z hat, 1, 1, 1. Now I have an R1, R2, R3, and R4. My R1 is going to be this guy, right? 1 in X and 1 in Y. R2 is -1 in X, 1 in Y. R3 is -X, -Y. R4 is positive X, -Y. Now, when I were to go back here, you'll see that I need to find R minus Ri all the time. I need to find this guy, R minus Ri. So R minus R1. If I do that, I'm going to get the xy cancel. So R is going to be simply, this is going to be simply z hat here. So if I do R minus R2 from this guy, it's going to be 2x plus z. Then R minus R3 is going to be 2x plus 2y plus z hat. Then R minus R4 is going to be 2y plus z hat. Not only that, I should find the R minus R1, the magnitude of it. R minus R1 is this, right? What's the magnitude of R minus R1? 1, right? R minus R2. This guy is going to be square root of 2 square plus 1. 2 square plus 1, which is square root of 5. So this guy gives R minus R3. The magnitude is going to be 3. R minus R4. The magnitude is going to be square root of 5. So you got all the equations to put in to the expression where you want to find the electric field at R. Is going to be 1 over 4 pi epsilon naught. I equal to 1 to 4 because you're having 4 charges here. And the Q is common, yeah? Q is common, the same, 3 into 10 power minus 9 coulombs. So I'm going to take the Q outside. R minus Ri over. So I'm going to substitute each of this guy, the 4 terms, into here. So this is going to be 10 to the power minus 9 over 4 pi. Epsilon naught, 8.854 into 10 power minus 12. Then I have how many terms? I should have 4 terms, isn't it? So the first term is R minus R1, which is z hat over 1 plus 2x hat plus z hat, the R minus R2 term over the cube comes in because of the 1 over R minus R1, the whole cube term. Then comes the R minus R3 term, this term here, over 3 cube plus the last term, 2y hat plus z hat over root 5 the whole cube. So when you go ahead and do the math, it's going to be 6.82. And in this case, in those 4 locations, all the charges were the same, 3 nanocoulomb. If it were different, then you will be multiplying this by, instead of q, you will be multiplying it by qi. And in this case, all the qi turns out to be the same. That's why you could bring the q out.